Alright guys, so with this tutorial I hope to shed a little bit of light on the topic of four-dimensional shapes and gloving. So this is going to be pretty intensive. um, it gets kind of weird. Basically we'll be using projections and cross-sections to represent four-dimensional shapes in three-dimensional space. And I'm going to be using the example of the Tesseract, which is a four-dimensional hypercube. And most people are familiar with the projections, where you have sort of the small cube nested inside of the big cube. This is the projection with perspective. And it sort of and you rotate that in the fourth dimension, and it sort of goes in and out of itself. And really, it's if I remember right, I think it was like 8 cubes if you like unfolded it, but you really only have to worry about a couple. But I don't use that one too much. We only have so many fingers, we can only represent so many edges, but it is nice for, say, if you're moving around using like digital liquid and you want to sort of do some weird stuff and kind of like maneuver around, because sometimes you just kind of want that weird, like, creepy crawly looking, like confusing but makes sense but I don't know why type feel. Now what most of this is going to be explaining is cross sections, because that's where it's more usable in my opinion, and it makes shapes that are very clearly out of the ordinary. Like, you can tell something's up when you're using four-dimensional cross-sections. Like, something's going on that you need to figure out what the hell that is. So I'm going to use analogies to explain this. So think of the analogy of having a three-dimensional cube passing through a two-dimensional plane, this right here. And if you pass that in like flat side first, you just see a cube, like boop, there's a cube, and boop, it's gone after a while. It's not too exciting, but what that does with 4 dimensions, just to help you get a picture of how these shapes act. What happens is you will get a cube sort of come out of a point, and it'll stay there for a little bit, and then it will shrink and boom, it's gone. That's gone. The second analogy is going in edge first. So going in like one line like that, when it passes through, you see a rectangle, or you see a line turns into a rectangle, eventually comes out kind of like an elongated rectangle. Like, it switches, it turns into a cube, and then the shorter side turns to the longer side, a little bit longer, and then it shrinks back to a line, and then it's gone. And then the third analogy is passing it through corner or pointy end first. Say like that. Passing that through, you see a triangle pop into existence. Sort of a fourth side comes in, and it does some weird stuff, and then it turns into another triangle, like facing a slightly different way, and then it goes away into a point. So these are the 3 analogies to keep in mind. So back to the 4th dimension, now that we have those and the boring one out of the way. So what you're going to imagine passing through edge first, it's going to have a little bit of properties of both the going through edge first and the going through pointy end first, the corner first of the two-dimensional one. And it'll start off as a line and come out into like a prism shape. So that's going to be sort of that like edge first analogy component. And then the corner first analogy component is what actually happens on each side here. That and there's just lines connecting each corner. And they don't like cross or anything. So don't worry too much about that. That's not the hard part. So you go open it up into triangular prism, and then it's going to sort of like shift into something with four sides for like pretty briefly, and then it'll sort of collapse back into a triangular prism again, like again facing a different direction. I'm not going to worry too much about specifics, about like super detailed specifics at least. And then it's going to collapse back into a line and it's gone. And you could think of different ways to represent that. I'm going to leave that up to you though, because if you're going to learn this, you're going to have to go balls deep. Just throwing that out there. You're going to have to look up like a lot of animations and YouTube videos, and you're going to need to have sort of a mathematical mind to understand it. And then the analogous one to going like pointy end first for a four-dimensional cube going through three-dimensional space is where it's like really strange. So I'll use this to represent the start as a point. My hands are going to have to be interlocking to do this accurately, and unless I went this way and then as this opened up I went in like that. So I'm just going to start here. So this one is going to rotate open into a triangular pyramid. So pyramid with a triangle base. 3 fingers are out. And then this one is going to rotate open, but when it rotates open, that fourth side has to come in. So rotate open. When you do that, you want to have your ring finger pulled back and sort of primed, ready to come out. And then when this opens, it rotates open the other direction. So say if this one went back, this one's going to go forward and vice versa. So back and forward. And now you have an octahedron, which is basically the 2 square pyramids stuck together base to base. And then this one is going to rotate. This one's going forward, so it's actually no, it would keep going backwards. So if it went back first, it would keep going back. Both the ring fingers come in when you do that. You watch enough animations, you'll figure it out how. It's weird. And then this one is going to keep rotating forward and come back either to there, or if you started here, go back to there. And that was quite a bit. And it's not easy. It really takes a lot of just doing it and doing it and doing it and looking at animations. A really good lecture to watch, actually. It's for this guy's book, actually. It's sort of promoting the book, but he talks about all the topics, and he has some good animations in there and analogies. If you look up on YouTube, things to do in the 4th dimension, it should come up. I think it was a Royal Institution lecture, but I'm not 100% sure on that. You'll know it when you see it. So I hope I shed a little bit of light on this topic for you guys. Maybe some more people can actually take this idea and make something, actually make something out of it. So let me know how you guys like this. Peace out.